Okay. So if nobody has questions on that, then let me talk about the next thing for grades. Okay, as I'm looking through outlines and book questions, your book questions look really, really great for the most part. Some of you are not showing work, and I'm not sure. It kind of looks like what you're doing is you're doing work on a separate sheet, and then you're rewriting answers, and you're turning the answers into me. I really don't care what your answers are. I care about what your work is and what your learning process is through the work. And I can't get that information from answers. So when you guys turn in book questions to me, make sure you are writing out the work and you are writing out labels. I'm going to preach this all year long, label units and molecules. And by the end of the year, I'm still going to have some people who lose points on tests and quizzes because they do not label units and molecules. You got to do it in practice. And if you don't do it in practice, you're not going to do it in the test. And I know some of you are sitting there thinking, I'll do it on the test. I'll just save myself some time in practice. It's not going to happen. People, do it. Do it in your practice problems. The other thing on like chapter stuff, outlines, some of the outlines I see are beautiful masterpieces and they are way too long. So the goal of the outlines is this. I want you to see the material once before we talk about it in class. Also, you're going to kind of get a framework for the concept as a whole. And then as we go through it, you should sort the concept in terms of priority, like what's important and what's just a detail. So when you guys are doing outlines, I want you to ask yourself this question. Is it useful to you? Is what you're writing down helping you to remember things? Is what you're writing down helpful to you in organizing your thoughts? Is what you're writing down taking you way too much time? I love a beautiful looking outline as much as the next person, but more than the beauty of what's on the paper, I want it to be useful. And if you're writing every single thing down, it's not going to be useful to you. You can't possibly retain all that information. Maybe try some different ideas. Maybe go through an outline and draw everything. Maybe go through a chapter and just do the practice problems. Maybe go through the chapter and just write out big ideas. Try different ways of outlining. I really don't want those outlines to take you hours and hours and hours. So try different methods and see if you can get those outlines to be really useful and practical to you without them taking your entire weekend. Does that make sense? Anybody have questions on that? Okay, see a couple questions. Yeah, some of the chapters are super long and they're just going to take you longer. And if you, what you might want to do for them is kind of break it up. Like we're not going to talk about the whole chapter on the very first day that we start it, right? So maybe you do look at the big sections, knock out 3 sections and see what we talk about in class. And then that night, as you're trying practice problems for that section, then outline the next section. Maybe that's more practical in chapters that are super long. Claire, can you ask your question out loud? I'm not sure I understand what you're saying.
Yeah, so are we doing the check-ins during a Zoom class instead of learning?
Oh, I'll probably give you a form to fill out.
Oh, okay.
And then maybe on a POGL day, we can have conversations about that form. Yeah. Okay. A couple other things as far as outlines go. When you attach your test reflection, I know I didn't ask for this, but I realized that I need to grade your free responses. And only a couple of you actually attached your actual test. So if you guys could go back and attach, all I need is a picture of your free response answers because I want to grade through that stuff and give you guys feedback on your free response answers. Also, I realized I never collected labs 1 or 2 from you. So at some point in time this weekend, if you could just take pictures of that stuff, I put documents for you to like insert those pictures into on Google Classroom. Some of you are attaching PDFs instead of inserting pictures into the document, and that is perfectly fine. Those are just as easy for me to look through as long as you label your sections in your lab really well. They're just as easy for me to look through as like inserting pictures into a document. And then same for the PES POGL. I never asked you for that. So I will. I'll put that up for you. Okay. So I think that's all I have to talk about in terms of assignments. Anybody have questions or comments on assignments? Peyton, you threw your test away. Don't do that. Don't do that next time. Just give me free responses for next time. It's okay. We can get a like clear view of your work without one free response from a test. It's fine. Okay, last thing is expectations on tests. So we've taken 2 tests now and a couple quizzes, and you guys have kind of seen like what the test is and what pacing it's like and what kind of questions get pulled out from the material and what kind of questions don't. So I wanted to talk about your grade on your test so that we have like tempered expectations. So all of the questions I ask you on tests and quizzes come from old AP tests, like AP tests that other students actually took. And I use AP test timing, and we use AP testing rules and references. And on the AP test, if you get an 80% or higher, you get a 5. So if you are getting, and that's a really rough score. So if you get like an 80 or above, it's a 5. If you get a 70 or above, it's a 4. A 60 or above, it's a 3. So a 60% in like high school world would be a D, and that's a pass on the AP test, right? And 80% would be a B in high school world, and that's like a perfect score on the AP test. And so the AP tests are significantly harder than normal tests. In our like normal AB schedule, my grading scale, if you got an 80% or higher, you would get an A in this class. And so the AP tests are designed to push you, right? They're not designed to like pat you on the back and make you feel good about yourself. I mean, we all need that once in a while. We need people to pat us on their back and say, I love you and you're special to me and you're wonderful and the most genius person I know, right? We need those people, but the AP test is not those people for you. The AP test is going to push you and push you and push you. And so you need to kind of temper your expectations and temper how hard you're being on yourself. If you get a 60% on a test, you take a deep breath and you go figure out what kind of mistakes you made so that you don't make them next time. And you know that you're going to get better at this. And then the next time, maybe you get a 70% and you realize that you have grown as a student in a really big way if you jump from a 60 to a 70. And also know that you're not going to be like, let's say you set the curve on the first unit and you may not set the curve on the second unit and you may set the curve on the 8th unit. I mean, we're all going to have our like highs and lows, and you don't have to be perfect at everything in chemistry. You're going to love some stuff and you're going to hate some stuff, and that's okay. When you go get your doctorate in chemistry, you're going to choose one of those areas to specialize in, not all of them. And that's okay. That's a good thing. So give yourself some grace, especially on those tests. My average on the first unit test is usually like a 45%. So if you beat a 45% on that first test, you did great. Good job. And if you didn't, you're going to grow, you're going to learn, and you're going to look at your mistakes and you're going to get better at this. And that's okay too. You will get there. So I just wanted you to kind of like temper your expectations and give yourself a little bit of leeway there and lower the panic. Okay. Questions, comments, concerns about tests or assignments or grades? All right, we're going to do practice problems today. So the answer to the warm-up, most of you guys hit it. You can only use M1V1 with dilutions. You can only use it if your moles of what you're looking at stay the same through the problem, and that only happens with dilutions. So it's a really useful formula as long as you know when to use it and when not to use it. Oh, I also wanted to show you the week at a glance. Good thing I wrote that on the slide or I would not have remembered. Okay, so today we're doing practice, right? We're going to do some practice problems. Your asynchronous time, we're going to go into a lab next. So I really don't want to go into new material in the middle of that lab. So your asynchronous time, I want you to take a minute and look back over chapter 4 and kind of revisit some things that you don't feel great about. Put a question about that thing in the Google chat, and then maybe look through the Google chat and answer someone else's question. That would be a really good use of your asynchronous time. Your homework is going to be all the pre-lab stuff on our third lab, which is investigation 4 in this book. So all of these things listed for homework are from investigation 4 in this book. So I want you to have that done coming into Monday's class because, I should have put that on as an assignment too. Okay, I will. I will put that on as an assignment on our Google Classroom because I want to deal with questions you have off of it in class on Monday. Okay? All right. So that's also on Classroom. All of that's on Classroom. All right, let's do some practice problems. Let's start here and try our molarity skills. No calculator. Let's see how long this takes you. And go. That was a minute. Okay, that was a minute and a half. Do we have answers? Ooh. We do have answers. All right, so you're looking for things that reduce well for you on this. We're going to set up molarity, right? Moles per liter. So we have grams and grams per mole, 60 grams times 180 grams per mole will be on the top for you. And then enough distilled water to make 0.25 milliliter. All right, so that's basically your setup. Now, I do better with fractions than I do with decimals. You may be the same or you may be different. So this is how my brain would process this. 60 over 180 is going to be, my color's not working out well, 1/3. And then this 0.25 is 1/4. And so I can combine these into 4/3, which is 1.3. And then you have to decide how many significant figures can you keep. So all of your answers, 4, 4, 4, or all of your initial information is 4. So you should be able to keep 4. We're not ever adding or subtracting. We're only multiplying and dividing. So the number of sig figs you end with is the same as the number of sig figs in your original answers.
I have a question.
Yeah.
So this kind of applies to a lot of the questions that we do, but how do I know which number to start with? Like the 60 versus the 250?
Yeah, so what I would do is as I'm reading through here, I literally write on my tests, just like I've written on this. I'm going to underline information. When I get to the question they ask me, my goal is to circle one word. So when I have that one word circled, I know I'm going to look for molarity. No matter what else they give me, I'm looking for molarity, and that's where I would start. I would say, okay, I want molarity. Okay, molarity is going to be moles per liter. Now, do I have moles and do I have liters? I actually do have liters, 0.250, so I can plug that one in right away. I don't have moles. Okay, so now, do I have information that I can use to figure out the moles? And I do. I have, if you look at, I love the mole hole graphic. You may have noticed that by now. They give me grams and they give me a gram to mole conversion. So I can get 2 moles from that information. So that's how my brain figures out what I am going to start with and what I'm not going to start with. I always go to the thing they're asking me first and I work from there.
Okay.
Does that help?
Yeah, a little bit.
That would be a really good question to ask different people in this class. Say, where did you start and why? Why did you start there? Because different people are going to process this information differently. And it might be useful to ask multiple people, what direction did you approach this? And then you can kind of figure out people who kind of think the same way you do, or maybe learn new ways of thinking and processing through questions. I feel like that'd be a really helpful question to ask around.
Okay.
Yeah. There's another question here. What does the mole raised to the -1 change in the problem? Mole. Where do I have that? Sydney, do you want to ask that out loud? The molar mass right here. That's going to convert your grams to moles. That's the only reason you can convert grams to moles. If you didn't know the molar mass or they didn't tell you what this was, you wouldn't be able to find the molarity because you wouldn't be able to convert from grams to moles. You'd be able to find the density. It means moles in the denominator. I don't see moles in the denominator. Oh, I see what you're talking about in the actual problem here. Yeah, anytime something is listed as the inverse It means they're writing it in the denominator. Yeah, thank you, Callie. It's just to save them, because when they write out something like 180 grams slashy line mole in a sentence, it's not, I don't know, it can be kind of like deceiving or misleading. And so this, you'll see it written like moles raised to the -1, just to make the sentence smoother. But it's that -1 only applies to the thing it's attached to. So if it's not like inside parentheses, it's only talking about the moles. It puts the moles in the denominator. It's not describing the grams. The grams is still in the numerator. Any other questions off this? Okay. Good questions, you guys. Keep those up. Let's try another one. And go. Okay, that was a minute. And that was a minute and a half. So notice that math problems take a whole lot longer than the concept problems. So when you can save yourself some time on the concept problems, you're going to use it on the math problems, right? All right, so 0.2 mole sample of MgCl2, 0.1 mole sample of KCl, dissolved in water, diluted to 50 mils. What is the concentration of Cl minus? Okay, so if I'm doing concentration and then they're telling you that concentration is measured in molarity, you're going to go, again, you want moles of Cl minus over liters total. That's what you're looking for. So do we have any of that information? Yes, we have 0.5 liters of solution. Do I have moles of Cl minus? No, I don't. So that's something you're going to have to find. So here's one set. Here's one source of Cl minus. So if I have 0.2 moles of MgCl2, I don't want that in MgCl2. I want that in terms of Cl. So if I have one molecule of MgCl2, that's going to release 2 ions of Cl. So I'm going to have 0.4 moles of Cl minus. What about KCl? You're going to go moles of KCl to moles of Cl minus. And in one KCl, you'll find 1 Cl minus. So 0.1 moles of Cl minus. So in this solution, magnesium chloride is going to dissolve to form 0.4 moles of Cl minus. Potassium chloride is going to dissolve to give 0.1 moles of Cl minus. And together, they will add up to 0.5 moles of Cl minus. So your answer is E. Okay, 3 of you beat me there. That's awesome. Questions on getting there?
Nope.
I know some of you had questions because only 3 of you beat me there. Please ask them.
I just don't understand how I just can't do it that fast. It takes me so much longer than that. Maybe it's because I haven't practiced, but I feel like I would have needed another minute and a half to get that. Because it takes me so long to think about what's in it and then how to get what I need. It's just hard for me to do it in a short amount of time.
Yeah. And
what I start with and what I'm going to.
Say that again?
I said it's hard for me to figure out like what I'm starting with and what I have to get to.
Mm-hmm. Yeah, both of those needs are expressed really well. Yeah, I hear you. If you were given like unlimited time, or if AP Chemistry was your only class, it would be so much more doable, right? So part of what the AP College Board is pushing you on is like proficiency, like how fast can you get there? And so if you're sitting here in the middle of the unit and you can't get there that fast yet, that's okay, because you haven't done all the book problems yet. You haven't studied, you haven't practiced. And the more you do that, you're right, Lainey, the more you do that, the easier this is going to get for you. And same for you, Kaya, to kind of evaluate the question and figure out what you want in the question quickly. That's a skill, right? And that's why we have from September until June. Well, May. I guess May is our test. Because that's a skill we want to get better on. And the fact that you recognize that's something that you want to grow in is a really powerful thing for you to have recognized. That's the first step to getting there, right? For both of you guys. So I hear you. Yes. Time. You'll get there. Practice, repetition. That's how you get there. I used to describe this class as a roller coaster. Like you start super excited for chem and then you realize how hard it is and the roller coaster just plunges, right? You're going to plunge for a while when you realize, oh, and there's this skill I need. And this is really hard. And this is a skill I need. But eventually you're going to start realizing the roller coaster is going to start climbing again. And you're going to realize like, oh, I'm getting better at this. And I can do this faster and all of these things. And usually you really hate me right before Christmas. And usually you kind of like break through the clouds and the sunshine turns on again at the beginning of like second semester. Maybe around like February, you're like, oh, I am growing. Maybe Mrs. Martins isn't the devil. Maybe I can do this class. Maybe I will score well in this test. So I hear those emotions. They're real. I'm sorry. Growth is hard, but you're going to get there, I swear. Let's keep doing practice problems. Let's see. Where's another one? Here's another one. All right, so this is similar math, but in terms of titration this time. And go. Oh, that was, oh, never mind. You have 10 seconds. Okay, that was a minute and a half, but I'm going to give you another minute to think and process through this question. This is a long one. And any questions on the problem before we start talking about it?
Could we talk about it, please?
Yeah. Yep. Okay, so the one of the things that they do that's a little tricky on this problem is in the like information here, they reference molecules like KMNO4, but in the reaction, they reference the ions that are formed or that like come off of here. Notice that K plus isn't involved in the reaction anywhere. What do we call an ion that's not involved in the reaction anywhere? Come on, make your chem teachers proud. Yes, sodium. Sodium is this also. It's called a spectator ion, right? K plus and Na plus are spectator ions. They don't change through the whole reaction. And so actually in the reaction, they just don't write them at all. And then they're asking you for moles of carbon dioxide. So we can actually ignore everything in this reaction except for those three things. And so the other thing on this one, as we're talking about like how do you know where to start? Whenever they give you a whole reaction and they're giving you multiple things in the reaction and a whole lot of information, I naturally go to the ice chart that I showed you the other day. Otherwise, it's just a whole lot of information that I have a hard time keeping track of. And so I would kind of rewrite this. I guess that's a hard color to see. Okay. MnO4 minus 5C2O4 2 minus. We really don't care about hydrogen or manganese, so I'm going to skip those and not write them at all. 10 CO2, and we really don't care about water either. Okay, so those are the three things I care about. Now let me look at information. They're asking me to convert to moles of CO2. And so in this information that they give me, I really only care about stuff that's going to get me through the mole hole to moles of CO2. So what I really need is moles of KMNO4. So I'm going to convert from liters into moles right away. Liters into moles. Same thing over here. Liters into moles. So this is going to be 0.004. This one's going to be 0.005. And if this is moles of manganate, to get to moles of carbon dioxide, I would need to get out of manganate and into carbon dioxide. Same thing here. Out of whatever that is, oxalate maybe, into carbon dioxide. Questions so far? Okay, so what would this be? 0.04 divided by 2. 0.02 times 10 would be 0.02. And then 0.05 divided by 5 would be 0.01 times 10 would be 0.01 moles of CO2. moles of CO2. So this one is going to be how much CO2 I can actually produce. I will run out of that C2O42 minus before I can actually use all of my permanganate. So my answer is D. It was a lot of information processing in that question. That's a long question. Questions, comments, concerns on this one?
I'm curious why they don't write the potassium. It seems important to the molecule or whatever.
It's only important in terms of what you're going to go pull off the shelf and put in your beaker. After that, it's really not important at all because it's a spectator, right? The reaction's not dependent on its presence. The reaction doesn't use its presence at all. And so what you have here, this reaction would be a net ionic reaction. Remember we talked about those in chemistry? It only shows us what is going to influence the reaction. It doesn't show us anything else. There could be tons of stuff present, but if it's not affecting the reaction, they're not going to include it. Yeah, that's a good thing to note, Ryan. Okay, that's class. We got through some good practice problems. We'll do a couple more. Maybe we'll do them Monday before we really get into the lab. If anyone has questions, I'll hang out for a couple minutes and answer those. If not, have a good day.
On the last part, why did you choose 0.01 instead of 0.02?
Oh, because, so if I use all of the C2O42 minus, I can produce 0.01 moles of CO2, right? If I use all of my manganate, I can produce 0.02 moles of CO2. So one of these things is going to run out and stop the production of my products. Which one's going to run out first?
C2O42 minus?
Mm-hmm. Yeah. So because C2O42 minus runs out and stops the reaction, I can only produce 0.01 moles of CO2. The reaction can't keep going forward to keep using permanganate and make more carbon dioxide.
Okay, that makes sense.
Yeah. Good question. Other questions?